Today we're going to look at some strategies to help us figure out whenever we're looking at a word problem or a story problem, how do I know if I multiply or if I divide? So in order to do that, we're going to start by filling in this Venn diagram. We're going to look at some similarities and some differences between multiplication and division. And I like to kind of color code in my classroom. I color code a lot. The kids will tell you that multiplication is always pink. I don't know why, I just picked those colors. And then division is always blue. So we're going to keep with that consistency. Well, let's go ahead and start by looking at how multiplication and division are similar or what they have in common. The most important thing to think about is that they both have equal groups. Okay, this is the most important differentiator between multiplication and division versus addition and subtraction. So that's what we really want to concentrate. Equal groups, equal groups, equal groups. Okay. Then another similarity that they have is that they share fact families. Okay, and what I mean by that is, let's take 3 times 5, for example, is 15. 5 times 3 is 15. And then I'll do it up here. 15 divided by 5 is 3, and 15 divided by 3 is 5. So it's the fact that we just reuse all the same numbers for these. So now that we know what the similarities are, let's talk about some of the differences. For multiplication, we like to use this little mnemonic device that spells out Egypt. And it stands for equal groups you put together. And then for division, it's Egypta. Now, it's not really a word, but we just roll with it. It's equal groups you take apart. Okay? So what else? When you look at multiplication and you're reading a word problem, more than likely, or you will always find that they're going to start off by telling you about parts or pieces. For division, they're going to give you the total or the whole, depending on how it's worded, but usually the total. For multiplication, you are going to be seeing or doing repeated addition. And for division, you're doing repeated subtraction. Now, I'll go over these more in detail in another video, but right now we're just doing contrasting the differences. Okay, for multiplication, we are going to be combining groups to find our total. Whereas division, they're going to give us the total, and then we are going to separate groups. For multiplication, since we're starting with parts and pieces, you'll notice that our numbers start smaller and they get bigger. For division, we starting with our total, so the numbers start as a big number and then we get a small number. Okay, so what pattern do we see here? When we look on each side, we can see that multiplication and division are related because they are exact opposites. And in math, we call that inverse operations. Okay? So everything we looked at on this side and that side, everything is the opposite. Cool. So one thing that I find that a lot of kids sort of get confused about is, well, how do I know if I multiply or add then? Like, you're telling me that multiplication is repeated addition, so why can't I just add? Well, let's look at our example again when we said 3 times 5. So the way that we always practice reading this multiplication problem is 3 groups of 5, okay? 3 groups of 5. So that means we're going to have 5 plus 5 plus 5. 1, 2, 3 groups of 5. Now that's easy. I can just skip count 5, 10, 15, or I can count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what's the point? The point is that this is faster than counting all of these up. And a lot of times before kids know their multiplication tables, they're going to be drawing out these pictures, or they will in the classroom, and they can also do at home, is they'll be using manipulatives like this to sort of, have something that they can count up. And so our goal is to get them to move away from that, because at some point, are you going to do 85 times 5? Are you going to draw out whatever 85 times 5 is? Are you going to draw out that many dots? No, it's going to take forever. Even if you wanted to add it like this, that gives us a lot more opportunity for errors. If I was to go ahead and add these up and carry and then add all of that up, what about 85 times 85? Am I going to write it 85 times? No. So this is why we're trying to teach them that multiplication is a faster way to do repeated addition. Now, again, they will try to figure out, well, how do I know with these smaller numbers, how do I know if it's multiplication or if it's addition? Well, with multiplication, remember, we always have equal groups. So again, 5 plus 5 plus 5, whereas let's say we saw these numbers in a word problem and there was a 3 and there was a 5, they might think, well, I should just do 3 plus 5. You'll see them do that all the time. 3 plus 5 equals 8. Well, they actually wanted you to do 3 times 5 equals 15. 2 different answers. So the difference is that with addition, our groups are not equal. Whereas when we multiply, if we say it correctly, 3 groups of 5, then we get this instead of this, okay? And it's the same thing with division, except it's just subtraction, okay? So let's look at an example and see how can we tell, how can we tell the difference? So I talked to the kids about looking at the word problem, reading it more than once, and looking for clues, okay? So let's go ahead and read this word problem. It says Sarah's mom, let's make it a little bit bigger. Can we? Yep. Okay. Sarah's mom made cookies for a snack at the party. She made 48 cookies. There were 12 children at the party. If each child got the same amount, how many cookies did each child get? So some of the most important things for us to point out is that they're telling us, that she made 48 cookies. So what's that telling us? 48 cookies. We already know our total. And then it says there were 12 children at the party, and each child got the same amount. That tells us that it's either multiplication or division because each child got the same amount. We're sharing equally. That's how we know it's not subtraction, okay? So the children, the 12 children are, in this case, are 12 groups. And so we want to know how many cookies did each child get. So we're looking for the group size. We already know the group amount. There's 12 groups or 12 children. So these are the things that we're looking for. The total is the biggest thing that tells us that is division. They already gave us the total. Okay, let's look at this problem. Hector's mom made glasses of lemonade for 4 of the boys at the party. Each glass of lemonade had 3 ice cubes in it before his mom poured the lemonade on top. How many ice cubes did Hector's mom use? Okay, so Hector's mom made glasses of lemonade for 4 boys. We got 4 boys here. And then each glass of lemonade had 3 ice cubes. And then it wants to know how many ice cubes did she use? Well, they told us how many she used in each glass, but we don't know how many she used all together. We don't know the total. So in this case, if we're looking for the total, then we're doing multiplication, okay? We don't know our total. So this is kind of how we teach our kids to be detectives and look for clues. We try not to teach words like each to tell you whether or not it's multiplication, because it could be a division problem that also uses the word each. Like it says, if each child got the same amount, how many cookies did each child get? So you don't want to just go in here and say, oh, okay, 48 times 12, which is what they will do sometimes. So in this case, I did underline each, but it's not to just point out the words. It's more so to understand what's going on in the problem. And you'll see, and this is in the next video, you'll understand why we use representations, because then as we draw out what we think is happening in the problem, then you can compare your drawing to the story problem and see if it matches. If your drawing doesn't match or your representation doesn't match, then you know that there's something else that you need to adjust.